All right, we continue on with our answers videos. This is part 2, and we're going to start on 6A. So what is the molarity of 1.7 moles of lithium hydroxide in let me read that again, because it's a significant difference and it's a common mistake. What is the molality of 1.7 moles of lithium hydroxide in, and this is a little odd, let's scratch this out. So let's make it 1.19 kilograms of water. Okay, so molality, write out the definition, and it's small m is the abbreviation for molality, and it's moles. Okay, so molality, moles of solute, exactly the same as molarity, but the denominator is different. It's kilograms of solvent. In almost every case in this class, the solvent's going to be water. All right, so they're asking for molality, so we're going to write that. Rather than small m, you want to break it down into its component units there. And specifically, it's LiOH here. Okay, so in this specific case, that's how you would write molality for this. All right, so we've got this many moles in so many kilograms of water. Very straightforward problem. Okay, moles on the top are what we need. Moles on the bottom are what we need. You don't even need to do a conversion in this problem. It's just a division problem. And that's our final answer. You really should write it, if you're doing this on the AP, as 1.4 small m. You don't have to write what all the solutes and solvents are. Just that's the way the final answer should normally be expressed. I don't think they would mark you off if you did that, but that's really the way molality should be expressed. Okay, so you go ahead and do 6B. Okay, number 7A. What is the mass percent of 67.1 grams of strontium oxide in 145 grams of solution? All right, so let's look at what the formula for mass percent is. It's grams of solute over grams of solution. Now, there could be more than one solute in the solution. There could be several. So it would be the grams of everything. So grams of whatever solute you want to find the mass percent of over grams of solution, and it's times 100%. So you're not converting anything to moles here. In fact, you need everything in grams. If you're given moles, you're going to need to convert it to grams using a molar mass conversion. All right, so let's go ahead and write this formula out. Okay, so come over here and write the specific components of this. Okay, when we get this, we'll then multiply that by 100%. Okay, so it's simply this. Okay, so our units on the top match up, our units on the bottom match up, so it's just a division problem. And then what we're going to do, though, is we're going to multiply that by 100%. Well, since I wrote this over here as this, let's go ahead and just do that. And we get this. So I just broke it out this time just to show you the two parts. So now, once you get that, that's not the mass percent. Okay, and that's the final answer. That's all there is to that. So just some basic problems to get you used to these different measures of concentration. Okay, we move on to 8A. Okay, what is the mole fraction? And it's represented by this Greek letter chi. It looks like a kind of a scripted X. So mole fraction, everything has to be in moles. So let's go ahead and look at the formula for that. It's somewhat similar to mass percent. It's moles of one solute over moles of the entire solution. Okay, solute, solvent, everything put together there. And everything has to be in moles. You do not multiply by 100%. It's a mole fraction. So mole fraction is used in partial pressure problems. I'll just give you a quick example of that when we do this problem. Okay, let's go ahead and do that. So let's write out the formula. You don't, when I said I'd like you to write out the formulas, do it on one problem at least. You don't have to do it on every single problem. So this one, though, we're going to do it. So chi equals, okay, so that's what that would be. So in this particular problem, we have grams. So the moles of solution is going to be the summation of all of the solutes and the solvent together. So a lot of times you have to break this problem up. You can't do it in one just nice long line of conversions like we've been doing. So what we need to do first of all is, let's go ahead and write this. So it's going to be, okay, so let's look at what we have to do here. Everything's in grams. We need to get it into moles. So we need to do a molar mass conversion for KCl. We need to do a molar mass conversion for water. And so let's go ahead and do that down here at the bottom. So we'll start with KCl. And we bring in the periodic table. You can look at your own. It's a little hard to read mine on the screen. It's 39.1 for potassium, and it's 35.45 for chlorine. So now you add those two together to get the molar mass for potassium chloride. Okay, and what we come out with is that 1 mole of potassium chloride is 74.55 grams. So hopefully you're experienced enough to just go ahead and do this kind of quickly. You don't have to write out all the conversions every time. So it's 1 mole. We need to get everything into moles. So grams of KCl on top, on bottom, grams of KCl on top. You end up with moles of KCl. So it's 45.7 divided by 74. And that gives us 0.61. All right, let's go ahead and do water. We have 132.4 grams of water. And a lot of you have this one memorized by now. H2O, 1 oxygen is 16. 2 times 1.01 is 2.02. You add those together, you get 18.02. If you had that memorized, you don't have to show the calculations. Just go ahead. Molar mass should be something that's kind of automatic by now. Okay, grams of H2O, so it's 132.4 divided by 18.02. And that gives us 7.3. Okay, so these are the two numbers we need to work with. So now what we're doing is we want to know the mole fraction of KCl. So the moles of KCl is going to go on the top, so I'm going to kind of move that up here. And that's the number we got for it. And on the bottom, it's the moles of everything, moles of solution. So you have this. It doesn't matter that there's different substances. They just want to know the total number of moles. Different substances, I mean KCl and water. You can add them together. And this is the moles for water. Okay, so now you just do the math on that. Okay, and it's 0.61. Let me show you how to do this. It could be a little tricky. 0.61 divided by, now I'm going to use a parenthesis because it's going to want to divide before it adds. That's just PEMDAS. That's orders of operations. So you have to put it in parentheses to be sure it adds this denominator before it does the division. Okay, so we're going to do 0.61 plus 7.3, close the parenthesis, and there you go. You get 0.07, and that's our final answer. So that's the mole fraction. And a mole fraction has no units. Everything's moles. They all cancel out. So it's 0.07. It would be 7%, but you don't express mole fractions as a percent. So what that means is, well, anyway, we'll use mole fraction in partial pressure problems a lot later on, and also in some acid-base problems. But that's your final answer. Okay? All right. So you go ahead and do 8B, and we'll move on to 9A. Okay, now we're going to come down to 9A, and ppm is a parts per million problem. It's very much like mass percent, except you want, instead of how many grams per 100 grams, you want it per million. So if we come over here and you look at the formulas, there's parts per million. Grams of solute over grams of solution. Looks just like mass percent there, except instead of multiplying by 100%, you multiply by the number 1 million. This is used, for example, by the water department to be sure the drinking water is safe. This is arsenic. You can't get all the arsenic out of the water. You can't get all the lead out of the water. There's other toxins. But as long as they're tiny, tiny fractions, then it's safe to drink the water. Your body can process those toxins in very, very tiny amounts, and so they need to measure those. All right, so let's go ahead and do this. So what we need to get is grams of solute. In the solute, I'll just go ahead and write what it is. It's arsenic over grams of solution. And then you multiply that by 1 million. And I told you the first time you use a formula, you should write it out. So I'll write it out here. Okay. All right, so we just need to put this over here. So we have grams of arsenic here. Draw a line here to keep that separate. So 0.81. Over 2.74 kilograms of H2O. So what we want to first do is, in this case, let's get kilograms converted to grams. So you should know the conversion. Hand out of the way there. There's 1 kilogram equals 1,000 grams of anything, not just of water, but of anything. Okay, so let's go ahead and do that conversion first before we stick it into our main equation here. Okay, so kilograms H2O and kilograms H2O cancels, and what you have there is 2,740 grams of H2O. Okay, so now what we can do is put in the denominator the grams of solute is going to be the grams of arsenic, so the 0.81 again, plus the grams of water. Okay, and what we're going to end up with then, just going to add all this up and then divide the top by the bottom. So again, on my calculator, I'm going to do 0.81 divided by, I have to open a parenthesis, be sure I add those two numbers on the bottom before the division takes place, plus 2740, close the parenthesis. So now that addition will take place before it divides it into 0.81 on the top. And it gives us that number. Okay, so it's 0.00.000. I'll just go 2 digits. I'm not worrying about significant figures here. That's it. Grams of arsenic for grams of solution. Now to get parts per million, you multiply that number times a million. So you don't have to clear your calculator. Just go ahead and hit times. So whatever that answer was, it says answer times, and it's 1 million. 6 zeros after the 1. You hit that, and you get 295. So the final answer equals 290, I'll round the 5 up to a 6, 296 parts per million. Okay, and that's your final answer for that. Okay, very small concentration. All right. We're now going to, I'm going to wrap up this video because starting with 10A, we get into a whole different type of problem, more advanced problems, and it's 10A on that I really want you to focus on. Some of these we did back in the day 18, day 19 assignment, but some of them we did not do, and so I want you to really focus on these. These are the really advanced problems that just kind of get you to the next level. These first 9 problems were designed really just to get you acquainted with the formulas. Okay, so I'll see you on the next video.